to 0. And then the whole thing simplifies to x is less than or equal to 0. Are we good so far with all the preconditions of 1, 2, 3, 5, and 8? Now, with all the preconditions done, then we can work on the post conditions. The post conditions, the first thing I can work with is post 3, for example. Now, post 3 is based on pre 3 because we already know the precondition of line 3 is this expression here. Is the right-hand side of line 3 reversible? If I look at it as a function of x, is it reversible?
Yes.
The answer is yes, it is reversible. So what we do is we use the usual way, express f of x as the right-hand side of line 3. Then the inverse function is just going to be x minus 1 is the inverse function. And since an inverse function exists, we use the substitution rule. So that, and after that explanation, then we can say post 3 is based on the substitution of pre 3. We take all the occurrences of x and replace all of that with the inverse function applied to x. And after that, it's just a matter of expanding all these things. So pre 3 is this expression. Let's put it here. X is x. And f prime of x is x minus 1. And then you just carry out the substitution. Then it becomes x minus 1 is greater than 0. And y is less than 0. You can leave it like this, or if you really want to, you can kind of clean it up a little bit and just say that x is greater than 1 and y is less than 0. Either way is fine. Any questions at this point about post 3? Okay, with post 3 gone, we can now move on to post 5, which is pretty much the same thing. I can use another letter. G of x is the right-hand side of line 5. So g prime of x is just going to be y plus 1 because the original function is y minus 1. To reverse that, we just have to add 1 to y. Oops, used the wrong symbol right there. Okay. And then we use the same explanation. So copy and paste. It's a good thing that you don't have to write anything on a piece of paper. Then you can use copy and paste and all those other things that you usually cannot normally do with your other classes with paper-based exams. Then you can say post 5 equals to substitution of pre 5, and this time remember to change the variable to y, and then say it is replaced by g prime of y, just like that. And then we just expand what is pre 5. Pre 5 is this thing here. Put it here. So y plus 1 is the inverse function. And that becomes x is greater than 0 is fine because it has no mentioning of y. And then this one becomes y plus 1 is greater than or equal to 0. And if you want to clean it up just a little bit, which is not required in the exam, you can say y is greater than or equal to negative 1. Are there any questions so far? No? Okay. Well, after that, we can figure out what is post 6. What is post 6? Line 6 is and if here. So once we know the post condition of the two branches, when the two branches merge, how do we figure out the post condition after the merge? Just an or. Just an or of the two post conditions, right? So it becomes post 3 or post 5. And since we have an editor, I do expect everyone to properly copy and paste it. Okay. Now the parentheses are important in this case because without the parentheses, the meaning of the expression would have changed. That's because, yeah. Oh. Pasted the wrong thing. There we go. Okay. Now the parentheses are actually important in this case because the precedence or the priority of the operators implies that the and would happen first, and then the OR will happen later. So without the parentheses, it will still have the right meaning, but it is not really clear anymore. You can look at the AND as a multiplication, and you can look at the OR as a addition. So it follows pretty much the same rules, but the extra parentheses definitely helps to indicate which one should occur first and which one should occur later. We're almost done. We only have post 8 to deal with now. Post 8 is based on what? Well, first of all, we have to take a look at the right-hand side of that. So we call this FGH. So we say h of y is the right-hand side of line 8. And then we say h prime of y, which is the inverse function, is what? It's just the negation of y. The negation of y is its own inverse function. Is that okay? No? Okay. Well, think about it like this. Okay, if I apply h prime to h and then apply everything to y, what do I get? What is h prime again? H prime is the negation, right? So we are looking at the negation of h of y. And then what is h of y? It's another negation. So we get y back. So this is basically a proof. H prime. Okay, I should not use my finger to point anymore because we're doing screen recording. Okay, so in other words, h prime applied to h applied to y gives y back to me. This is proof that h prime is in fact the inverse function of h. And in this case, they turn out to be exactly the same thing. Okay, I think in mathematical terms there are special names for this. It's like a reflective property or something like that. I can't remember my abstract algebra terms anymore. Okay, but the point is, since there is an inverse function, the way we figure out the answer is to use the substitution rule. So the substitution rule applied to pre-8. We place all the occurrences of y with h prime applied to y. And then we just copy and paste a bunch of stuff. Okay. Like that. And interestingly, after the substitution, nothing happens because there's no mentioning of y anywhere in that condition. Okay? Okay, so we're done with post 8. We already know what is post 6, so we can work on post 9 at this point. Post 9 is the disjunction of post 6 and post 8. Oops. Or, and then we just expand it. Copy whatever post 6 is, which is a big, huge mess. And then the other one is not so big of a mess. But I would just leave that as the answer. Okay? So for the final exam, because we do have an online editor available, I do fully expect people to expand everything. Okay, not just getting to this part here, but actually expanding the whole thing and use the proper level of parentheses to indicate the order of operation. Okay, any questions so